Okay, we've done something similar to this for ratio of areas in a previous topic. Now it is volumes of similar solids. Okay, all cubes, they are similar. Every single cube is similar to each other because all the ratio of their lengths will be the same. All the ratio of heights will be the same. All the ratio of perimeter will be the same, for example, for cubes. So in this case, whether you are using 5 over here and 10 over here, or 5 here and 10 over here, or maybe you like to use the perimeter, which is in this case this one versus this one, the ratio will always be 1:2. Okay, let's just take a quick look at 5 times 4. That is the perimeter, the black color part. That is 20 to 40. So it is still 1:2. Okay, so all these are measurements of length. They will be 1:2 if these two cubes are of these dimensions. So when we talk about the ratio of the volume, we're going to take 5 times 5 times 5 to get 5 cube. And on the other cube, we got 10 times 10 times 10, which is 10 cube. So we get, in ratio form, this will give us 5 over 10 cube, which is 1/2 cube. Now this 1/2, I need you to realize that it is from here. Same thing. Which therefore gives me 1/8. Okay? Sorry, why did I write square? This should be cube. So what we observe over here is that if the shapes, if the objects are similar, it looks like the ratio of volume is simply the cube of the ratio of sides. Compare this with area. If they are similar, the ratio of area is simply the square of the ratio of sides. Okay, then let's check the next one. What is the volume of a pyramid? What is the formula? 1/3? Yes, 1/3 what? Base area times the height. Now this height in this case will be the perpendicular height. Okay? So here I've got side of 4 and a side of 6. Ratio of sides, it will give us 4 over 6, which is 2 over 3, right? 2 over 3. That is if I compare the base. What if I choose to compare the height? I don't want to compare the base, I want to compare the height. You get 6 over 9, which is still 2 over 3. It is not a surprise, because they are similar solids. Okay, if you like, you can even calculate. You can even calculate this diagonal length from here to here. That will be, if this is 4 and if this is 4, if this is a right angle, so 6. This one over here will be square root of 4 square plus 4 square. Right, Pythagoras theorem. Then this one over here will be square root of 6 square plus 6 square. Then if you find the ratio, you will again get 2 to 3. Always. So what do you think is going to be the relationship for the ratio of volume? Without calculating it, because we were just assuming that this is 4 and we were just assuming that this is 6. It might not be. They didn't say this. Oh wait, they did. Yeah, they did say it's square. So it is correct. This is 4 and this will be 6. If you want to calculate the volume, you will get 2 over 3 cube. Is it? Yeah, you are right. But let us prove it. Okay. I want to find the area of the volume of the small pyramid. So it will be. There's not enough space over here, so I'll do it at the side. Volume small over volume big. 1/3 base area. What is the base area for the small pyramid? 4 times 4. Then the height? 6. Okay, what is the volume for the big pyramid? Okay, 1/3. 6 times 6. 9. Okay, so let us cancel. Let us simplify. 1/3 and 1/3. Then the 4 and the 6, what do you get? 2 and 3, right? Are you surprised that it is 2 to 3? Shouldn't be lah. Because we already said ratio of sides is 2:3. Then over here 4 to 6 again. Cancel. 2 to 3 again. Not surprising at all. And finally the height. 6 to 9. Again, we get 2 to 3, right? You see this 2 to 3 repeating itself? How many times? 3 times. So, to simplify it, it will give us 2 over 3 to the power of 3. And this 2 over 3 is simply from the ratio of sides. Okay? So, ratio of volume, we will just write 2 over 3 and we cube it to give us 8 over 27. Cylinder. Okay, ratio of side, come. Tell me the answer. What's the ratio of sides? No, not 1 over 3. How much? Okay, 9. Ratio of side lah. 9 over 15, which is simplified to become 3 over 5. It is the same thing if we take 6 divided by 10, right? Okay, so ratio of volume. You want me to calculate for you? Or do you want to accept the answer already? Accept? You're all convinced already? Yes. Okay, very good. So the ratio of volume will therefore be 3 over 5 to the power of 3. That gives us... What is this? 3 cube need calculator, man. Yes. 27 over 125. So you see, although this is what I discover, and this is what you should discover also. Although this cylinder has a radius of 6, the largest cylinder has a radius of 10, it looks like it is 6 is more than half of 10, right? Half of 10 is 5. 6 is more than half of 10, right? So, intuitively, normally, we would expect that the volume of this small cylinder should just be a bit more than half of the volume of the big cylinder, right? Is it normal to think that way? Intuitively, since the radius is slightly larger than half, I would think that the volume is slightly larger than half. But is that really the case? No, it is not. If this volume is 125, if it is 125 units, what is the volume of the smaller cylinder? How much? It is 27 only. Right? That's the ratio given to us. If the volume of the largest cylinder is 125, volume of the smaller cylinder is actually only 27. Is that slightly more than half? No, it is about 1 over 5. It's about 1/5 of the volume. Okay? So, you need to know the relationship between ratio of volumes to the ratio of sides. They are not proportional. Okay, so now if you have a sphere, we've got a radius A to B, the ratio of volumes will therefore be A over B cubed. So if you write it in ratio, it will be A cubed to B cubed. Okay? So there's only one difference between this and the ratio of areas. The ratio of area, we simply square the ratio of sides. Okay, so this is the summary. Ready to do questions? So here we have two similar basins. This one, take note, keyword similar. So we need to straight away know, okay, ratio of volume must be the cube of the ratio of sides. The height 16 and 20. Find the ratio base area of A to base area of B. Are they asking for volume or area? Area. Okay, what is the ratio then? Without looking at the answer. Cube? 6. Okay, so the ratio part A will be 16 over 20 and we square it because they want area. Okay, so you simplify, you get the answer. In this case, 16 to 25. Next, capacity. What do they mean by capacity? Volume. So volume of A to volume of B, what is the answer? Cube of what? 16 over 20 when you cube it. 16 over 20, cube it. Answer. Simple? Yeah, simple. Yeah, it is not, you're absolutely right. It is not actually the volume, it is just a ratio. Okay? Okay, so let us try it 17. Part B. Let us just do part B. 1 minute. Volume of C to volume of D. And they want ratio, so final answer must be in ratio, not in fraction. Done? Do you have this? Simple? I'm sure you will do A, right? We just change all this volume to become area. This one becomes area. Then this one becomes a square. And here we have 16 to 9. So the area will be 16 to 9. And this will be the answer for part A. Okay? That's all that there is. Okay, I will stop over here. Have I given you homework for 3.3? Yes, sir. Are you sure? Yeah, I gave you homework already. It was due on 18. I think only 2 students submitted. I don't know. Okay?